Hello everyone, good afternoon. Uh, since time is already it's 4 p.m., so let's start our session. My name is Gaurav Kumar. I'm a research scholar and a Prime Minister Research Fellow at Department of Design, IIT Kanpur. Okay, and I'm working in the area of assistive technology for inclusive society, including the medical devices, mobility aids, and rehabilitation technology. And my aim is to design human centered to incorporate the human centered design in assistive technology. Okay, so I welcome you all in week 9 assignment solving sessions, product platform and product families. So balancing the variety, commonality and cost in design strategy. Okay, so okay, we, without wasting any time, let's start our session. Okay, so product architecture and module identifications. Okay, so the concept of product architecture lies at the very foundation of product design and engineering. It provides a framework for how a product functions are translated into a physical components and how these components interact within the system. So these sessions on a product architecture and module identifications so introduce you to the both the theory and practical methods that shapes the effective design decisions. So our primary objective is to understand what product architecture means and why it play such a pivotal role in managing the design complexity. Okay, so beyond the definitions, we will also explore the cons- contrasting the approaches of integral and modular systems. So, learning where each approach provides the value and what challenge they present. So, finally, this lecture emphasizes a systematic approach to model the identifications through both theoretical frameworks and uh, practical lab exercises. So you will gain the ability to map the product functions to components in a real world products. So thereby building a strong foundation for a design innovations. Okay. So basically what I'm trying to do here is uh, to provide to provide you the summary of whole 1 week of the course Functional and Conceptual Design by Professor T. Ashokan, IIT Madras. So whatever you guys have learned in last 1 week, week 9, so I am trying to give you a small summary, and after the completing summary we will have some question answer sessions. So these questions answers may help you to understand your subject in better ways, and it will also help you for your examinations point of view. Okay, so product architecture overview. Okay, so the product architecture can be defined as the structural arrangement of products, components and subsystems that together believe for its intended functions, and it acts as the bridge between abstract functional requirements and concrete physical form, guiding the design process from problem definition to tangible solutions. The purpose of architecture is to systematically convert a list of functions into a set of physical design elements by stabilizing this organized structure. So engineers are able to address user needs effectively while also considering manufacturability, reliability, and sustainability. So the benefit of well-designed product architecture extend across the product life cycle, and it simplify the complexity by creating a clarity in component interactions, enables efficient development through reuse and parallel engineering, and ensures better maneuverability, thereby reducing cost and time across the product's lifespan. Okay, so it basically give you the benefits that manage the complexity, enable efficient development, and it improves the life cycle maintainability. Okay. uh, Mapping functions to form. So the journey from functions to form begins with a clearly defining functions requirement. Okay, so these requirements describe what the product must achieve and independent of how it is physically realized. So a structured approach ensures that no essential user need is overlooked in the translations. Okay, so once the functions are established, they are transformed into a specific design elements. So this process of mapping the systematically allocations each functions to a physical component or subsystem. So ensures that every requirement has a tangible implementation within the product. So by assigning the functional blocks of layout structure, designers create alignment between product functions, components, and user needs. Okay. So this ensures not only technical feasibility but also coherence of product usability, performance, and customer satisfactions. Okay. Next is a type of product architecture. So there are a primary two type of product architecture. First is integrals architecture, and second is modular architecture. So each represent a different philosophy of how functions and components should relate to one another within a system. So integral architecture emphasizes the tightly interconnected functions and components. So in such a design, multiple functions are fulfilled by a single components, creating a compact performance optimized products, but at the expense of flexibility. And modular architecture, on the other hand, divides the product into a distinct independent modules with well defined interface. So these modules can be replaced, upgraded, or customized easily, making the design highly adaptable to market and technological changes. So next is advantage of modular architecture. Okay, so on the greatest strength of modular architecture lies in its ability to enable product customizations. So by swapping or upgrading the modules, products can be adapted to suit a different customer requirements without a complete redesign. So modularity also greatly enhance ease of maintenance and repair. Factually, modules can be replaced individually without disturbing the rest of the systems. so leading to lower downtime and improved user satisfaction. So furthermore, modularity promotes a parallel engineering and manufacturing flexibility. Different teams can work on a separate modules, simultaneously reducing the development time. So it also allows for variations in a product family to be produced at a scale while maintaining efficiency. Okay. Okay, moving towards the next. Next is challenge of modular architecture. Okay, so despite its strength, modularity comes with its own set of challenge. Designing modular products often require a high upfront efforts. Okay, and resource during the development stage, especially in a creating a precise interface between modules. So another challenge is that modular systems sometimes result in a large uh, overall form factors. So compared to integral designs, so this can be a disadvantage in applications where compactness or weight minimizations is crucial. Lastly, modular products run the risk of reduced performance optimizations, okay, because modules are designed for interchangeability and independence, so they may not achieve the same level of efficiency of compactness as a tightly integrated systems. Okay. Next is future of integral architecture. Okay, so integral architecture focuses on maximizing the compactness and performance by tightly linking multiple functions into a fewer components. So this design strategy often leads to products that are optimized for efficiency in their specific use context. Okay, so in some cases, integral designs may reduce initial complexity since fewer components need to be managed and assembled. So this can be advantage in our early stage prototyping or in applications where performance uh, outweighs flexibility. So however, the trade-offs are significant. Integral products are typically harder to repair as a components are interdependent. So they also offer a limited adaptability and scalability, making them a less suitable for markets that demand frequent updates or variations. Okay. Next one is product versus portfolio architecture. So the product architecture focus on the design of a single product where the primary concern is mapping as a functions effectively to form. The goal is to create a product that works reliably, performs as expected, and address a specific user needs. Okay, next portfolio architecture. So on the other hand, task a broader perspective, it addresses the structure of an entire family of products offered by a company. So the emphasis here is on managing variety, ensuring commonality across products and controlling cost while catering to different market segments. So together both perspective provides a comprehensive framework while product architecture derives the technical executions. So portfolio architecture shapes a business strategy enabling the companies to balance innovations variety and efficiencies. Okay. Next is whatever the in sir's lecture they given the laboratory exercise. So I am trying to give you a small summary about that also. So laboratory exercise is stated with this lecture provides the practical dimensions to theoretical learnings. So students are, as you have seen in sir's video, that they were asked with this dissecting the consumer's products such as CD players to explore how components corresponds to a specific functions. So the exercise involves the identifying the physical models, analyzing their functional roles and mapping these findings against theoretical model of the product architecture. So this process develops the critical observation skills and builds a deeper appreciation for the structure of everyday products. So there, though the hands-on instructions, students can better visualize and internalize the abstract concepts by connecting the functions to form mapping in a physical products. The lab reinforces the importance of architecture in guiding effective design. Okay. So next is a step model step in module identifications. So the first step in model identification is disabling a product and listing all of its visible components. So this creates the foundations for detail of functional analysis. Okay, so the second step is to construct a functional module of the product, mapping each part to the functions it fulfills. So this ensures that every physical component is understood in the context of its role within the large system. So finally, components are grouped into coherent modules based on their functional independence and logical grouping. So this systematic approach reveals how well a product has been architected and where improvements might be possible. Okay. So next one is mapping functions to concept. Oh. So mapping functions to component examples. Okay, so CD player offers a clear example uh, uh, of mapping functions to physical components. For instance, the motor shaft is responsible for rotating the disc, directly enabling the playback function. So the gear assembly then transfers the motions, ensuring that mechanical engineer is properly distributed for a smooth operation. So each gear play a precise role that directly support the product's intended functionality. So similarly, the optical lens systems reads data from the disk addressing by understanding how each of these physical part implement core functions. Students can connect the dots between theoretical architecture and the practical realizations. Okay. Next one is evaluating the modularity. So evaluating the modularity involves assessing the degree to which product modules are independent and self content. So high modularity ensures that functions are clearly isolated with minimal overlap between modules. So another important creation is interface simplicity. Effective modular design rely on a well-defined interface that allow modules to interact seamlessly without excessive complexity. So each of assembly and disassembly is also critical. So good modular design support quick upgrades, repairs and modifications. So making them valuable in dynamic markets where adaptability is the key. Okay. Next is practical implications. So the architecture of the product has a long-term implications for a cost, manufacturability, and service strategy. Okay, so decisions made during the design stage directly influence the efficiency in our productions and customer satisfactions during use. Okay, so modular products often enables the companies to introduce new variations quickly and cost effectively, so making them ideal for markets with a high uh, variety. Integral designs, however, are often chosen in the industries where performance and compactness outweigh the need for flexibility. So thus the choice between modular and integral architecture is not universal but strategic. So companies must weigh trade-offs carefully to align a design approaches with the business goals and market demands. Okay. So now the summary and takeaway is, so in a summary, product architecture provides the backbone for efficient and an effective product design. So it is the framework uh, through which functions are mapped into a tangible form, ensuring user needs are met systematically. So the distinctions between integral and modularity architecture highlights a fundamental trade of optimizations and compactness versus flexibility and adaptability. So understanding these trade-offs enables more informed design choice. So finally, module identifications and hints on lab exercise reinforce the theoretical learning, so by bridging the gap between concept and practice, so students gain both analytical skills and a design in intuitions, so preparing them for a real world engineering challenge. Okay, so this was the summary and takeaway of the last 1 week, week 9 courses. Okay, now we are moving towards question answer sessions. So I will provide you questions and as well as options. So based on that, uh, please participate wherever you are watching this video. So pause the video and answer yourself, and then I will also provide you the explanation part. So these questions may be helping you for your examinations or quiz points of view. So I would request everyone that please participate. So as you can see on your screen that our first question is that in which architecture are the interactions between chunks ill defined and sometimes incidental to the primary functions of the product. Is it modular? Is it integrated? Or is it fixed, unsaid, or none of the above? What with the right answers? Please pause your video and try to solve the problem. Okay, and then I will also provide you the explanation part. So I hope you all must answer the question. So now I am going to provide you the explanations. Okay. So it's about integrated architecture. So in an integrated architecture, different functions are combined into fewer components. So this design choice aims to maximize the compactness, reduce material use and optimize overall efficiency. So by tightly linking the multiple functions within one component, produce achieve a high performance with minimum redundancy. Okay, so however the trade-off lies in the nature of interactions between chunks. So unlike a modular system with clear interface, so integrated systems often show ill-defined or implic- implicate implicate the interactions. So these connections are not deliberately structured. Instead, they rise as byproducts of the tightly coupled design. For instance, in a smartphone, the display, touch sensors, and protective glass are integrated into a single unit. So that create a compact systems but makes the repair or replacements far more challenging. So one broken elements often means replacing the whole unit, reflecting the incidental nature of interactions. So in contrast, modular architectures keep functional boundaries clear, making upgrade or replacement so straightforward. So integrated architectures prioritize the compactness and performance but at the cost of adaptability and repairability. So the right answer for this question is option B, integrated. Right there. Okay. So now as you can see that here, that as I have also written the explanation part on this slide, that in an integrated architecture, a multiple functions are combined into a fewer components while it's achieve the compactness and optimization. So it also lead to ill-defined interactions between chunks. So these interactions are often incidental rather than systematically designed by contrast. So modular architecture has well-defined interface, so making integrations easier to manage and interactions more predictable. Okay. Moving to ask the next question, question number 2. Which of the following factors affect the modularity of the product architecture? Is it customer requirements, product change, functional analysis, or product performance? Okay, so please pause the video whenever you are watching and try to answer the questions, and meanwhile I will also provide the explanation parts. Okay. So I hope you all you must be have the right answers. So now I am giving you the correct explanations for this particular questions. So basically, the product modularity is shaped by external and internal drivers. So among these product changes and a product performance have the greatest impact. So a design that anticipates the change over time, such as upgrades or repairs, must allow for easy separations and replacement of modules. So the product change directly influence how flexible a design must be. So a modular approach accommodates the evolving requirements without redesigning the entire systems. So this adaptability is critical in industries with fast moving technology like electronics or software driven products. So the performance is another deciding factor. While modularity improves the flexibility, and it may sometimes compromise performance due to additional interface. So designers must strike a balance ensures the adaptability without sacrificing the efficiency, speed, or the durability. Okay. So the customer requirements and functional analysis do guide design, but they do not directly decide the modularity. So instead, it is the need to accommodate the future change, and it maintain the strong product performance that drive a modular architecture decisions. Okay. So B and D is the right answer, product change and the product performance. So you may go through this explanation slide. Okay, so as I have written here, the product modularity is strong influenced by a change in the product over time. Okay, and performance considerations. So customers requirements and functional analysis inform the design, but do not directly determines the modularity. So thus adaptability and maintaining the performance are the key factors in modularity decisions. Okay, now moving towards the next questions. Question number 3: which of the following is not an example of sectional modularity? Is it airplane, or computer, or office furniture, or drill bits? What will be the right answer? Which of the following is not an example of sectional modularity?
Drill bits.
Oh, okay. Somebody's here. Yeah, what you were saying, Om?
Drill bits. D option.
D option. Okay. No, answer is A. Okay, let me provide you the explanation. So basically, a sectional modularity describes the products where the standardized unit can be connected or disconnected easily. So like office furniture, computer, or drill bits. So these products can expand, shrink, or reconfigure without major redesign. Okay, and aeroplanes, however, does not fit this category because aeroplanes demand a highly integrated design for safety, aerodynamics, and performance. So each section is deeply interdependent on others, and replacing or interchanging sections is impractical and unsafe. So for example, office cubicles are sectional modular because panels can be rearranged to create a new layout. Similarly, drill bit sets allow bits of a different size to be swapped while retaining the same tool base. So these reflects the essence of sectional modularity. So therefore, while many engineered systems favor a modularity strategic, and airplanes the represent an integrated system. So their design prioritize the structural integrity and performance over a modular interchangeability, so making them an exceptions in this context. Okay, so the right answer is option A, airplane. As you can also see the explanation part. So now moving towards the next question. Question number 4. Which of the following belongs to the basic clustering method? Is it creating a rough geometric layout, or clustering element into module chunks, creating product analysis, or creating the function structure? Can you answer? Can you answer question number 4?
Creating function structure, D option.
Okay. Okay, let me provide you the explanation. So the basically clustering method is a systematic approach to identify modules within a product, and it begins with creating a functions structure which break down the product into smaller manageable sub functions. So this set the stage for modularizations. So next, designers prepare a rough geometric layout. So this helps the visualize the physical arrangement of functions and components, so showing how they might interact spatially. So by linking functions with form, the product begin to take a shape. So after these elements are clustered into module chunks, so components that share a strong functional or 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 spatial dependencies are grouped together. So this makes the design easier to manufacture, assemble, and maintain. So product analysis, while important, is not a direct step in a clustering the instead clustering focus on systematically transforming the functional requirements into a well defined module, those structures, so layout and grouping. Okay, so the right answer for this question is option A, B, and D. A, B, and D. Okay. Next, which of the following is not a limitations of the clustering method? Is it not satisfying the current and future needs? No systematic procedure for identifying the modules, or product family are not well defined, or module interactions are not well defined? What was the right answer? Question number 5.
E option.
Option A. Okay.
B, B.
Okay, B. No, A is the right answer. So basically, the clustering method is valuable for a modular design, but like any approach, it has its drawback. Okay, it often lacks a systematic step by step procedure for identifying the modules, which can make the result inconsistent across a different design teams. So another limitations lie in defining the product families, while clustering helps to identify modules, and it does not allow uh, clarity how those modules translate into a broader uh, product families or or a platform. So this can limit scalability. So additionally, module interactions are not always well defined in clustering. So designers may group components effectively but overlook the nuance of how those modules will interact in a real world use. So this can lead to inefficiencies or design conflicts. So however, one thing clustering does achieve is the ability to address both current and future needs. For this reason, not satisfying the current and future needs and cannot be considered limitations of this method. So the right answer for this question is option A, not satisfying the current and future needs. Okay. Question number 6. The heuristic method used to identify the modules include branching flow, functional flow, or conversion transmissions or customization transmissions.
C. Convergent transmission.
Convergent transmissions. Okay. But right answer is the branching flow and convergent transmissions. Both A and C both are the right answer. So basically, heuristic methods are practical rules or shortcuts used in a design when formal systematic procedure may not be sufficient. So in the context of module identifications, heuristics helps designers to break down the complex product into a meaningful cluster of functions and components. So they provide a design guidance based on functional flow patterns rather than strict formulas. So two widely recognized heuristics are branching flow and conversation transmission. So branching flow occurs when a dominant flow divide into a several subflow, such as power from a battery being distributed to a different circuits in a device. So convergent transmissions, on the other hand, involve a converting one form of input into another, like electrical to mechanical. Okay, so while transmitting the effect through the system. So these methods stand apart because they capture a natural pattern of how energy, materials, or informations move through a product. Identifying such a flow points help designers to logically define modules that align with the product's real functional behavior. Okay, so options such as functional flow or customization transmissions may sound similar but are not formally recognized heuristics in a module identifications. So designers rely on a branching flow and conversations transmissions because they directly correspond to a functional dependency observed in our physical systems. Okay. So A and C is the right answer. Okay. Next is question number 7. Identify the type of modular architecture shown in the image. So identify the modular architecture in this
C. Option.
slot.
Slot modular.
Okay, 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 cool. Right. So basically, slot modular architecture is characterized by systems where modules are designed to fit into a specific slots. So each with a unique interface. So this type of modularity is common in computing systems where components like RAM or a graphics cards must connect to precisely defined slot on a motherboard. So the advantage of slot modularity lies in its ability to maintain a strong functional independence while ensuring the correct placement of modules. So by giving each module a predefined interface, the architecture reduces the ambiguity and avoid potential mismatch in the design. So the compared to bus modularity, which use a common backbone for multiple modules, so slot modularity provides a more specialized interface. So the sectional modularity, meanwhile, the relies on sequential arrangements, and mixed modularity combines multiple strategy. So the image presented in the questions clearly demonstrate a slot based configurations, making slot modular architecture so the most appropriate answer. So it highlights how physical structures and interface design dictate the classifications of modularity. Okay. So you may go through this slide. Okay. Now moving towards the next question. Question number 8. The method of identifying the modules based on functional dependencies is called, is it module heuristics, fixed unsaid, mixed modularity, or subassembly?
A
What?
option.
Sorry?
A option.
Oh,
Module heuristic.
heuristics. Yes, correct. So, when identifying the modules, designers often need to analyze the functional dependency. So, the method dedicated to this is known as module heuristics. So, this involves the observing how different semi-independently. So, by focusing on functional relationship, modules heuristics provide a rational basis for a module definition. So functions that depend on one another for smooth operations are clustered into the same module, while unrelated ones are separated to maintain independence. So this approach reduces the design complexity and enhance the maneuverability. For example, in washing machine, the water control functions may be clustered together while mechanical spinning functions from separate modules. So this device that reflects functional dependencies, not just a physical grouping. So other options like a fixed unsaid, fixed uh, unsaid, mixed modularity, or sub-assembly describe the architectural pattern or assembly strategy, but not method of identifying the modules. So module heuristics remains the most precise technique for a functional dependency analysis. Okay, so the correct answer for this question is option A, module heuristics is the right answer. You may also go through this slide as I've written a small explanation part for this particular questions. So those who are watching this video later, you may please go through this slide. Okay. Now moving towards the next question. Question number 9. Okay. So identifying the type of module highlighted in the function structure of the pencil sharpener. Okay, is it dominant flow, branching flow, convergent transmissions, or transmissions flow? What is the right answer?
Convergent transmission.
Convergent transmissions. Okay, yes, you are correct. Convergent transmission is the right answer. So the operation of pencil sharpeners illustrate the concept of convergent transmissions. So the user input mechanical energy by rotating the pencil or handles. So this input is converted into rotational energy of the blades, which in turn transmit force to save off the wood and graphite. Okay, so just a minute. So this principle shows a direct conversion of human energy into mechanical actions, followed by transmissions of that actions through gear or blade movement. So without this convergence transmissions process, the sharpening functions could not be achieved effectively. Okay. Converge- Convergent transmissions heuristics are widely observed in tools and small appliance. So they ensures that user inputs are transformed into desired outcomes while maintaining a logical flow of energy and and material within the system. So other heuristics such as a branching flow or dominate a flow do not apply here because the sharpener does not split a single input into multiple flow. So instead, it clearly demonstrates the conversion of energy from one form to another with transmissions to achieve the cutting actions. Okay, so C is the right answer, conversion transmissions. So those who are watching this video later, kindly go through this slide. Okay, and if you have any kind of doubt or anything, you may drop an email to me on kgaurav23 at the rate iitk.ac.in. Okay. Now moving towards the next question, question number 10. Dash provides a concise descriptions of how the product will satisfy the customer needs. Is it design, concept, market, or customer?
Concept and design.
Concept and design. Okay. Okay, so basically a concept serve as a concise descriptions of how a product will satisfy customer needs, and it is the link between abstract user requirements and practical design solutions. So concepts outline what the product is intended to achieve without yet detailing the complete engineering design. So stage is critical because it allows stakeholder to evaluate whether the the proposed directions align with customer expectation and businesses goals. So a strong conceptual balance functionality, usability and feasibility before resources are invested in a detailed design. So unlike a design which refers to the implementations phase, the concept phase is about capturing the essence of these solutions, and it expresses the intended benefit and functional promises in a simple communi- communicable terms. So neither market nor customer descriptions provide this structured connections. Only the concept formally articulate the pathway from customer need to product satisfaction. So making it central to the design process. Okay. So concept is the right answer. And those who are watching this video, kindly go through this slide uh, explanation part. Okay. Now moving towards the next questions. Question number 11. Which of architecture allow components to be easily upgraded or replaced without redesigning the whole product? Is it integral architecture, modular architecture, fixed and shared architecture, or functional architecture? What would be the right answer?
B. Modular architecture.
Okay. Yes, correct. So, modular architecture is designed with a well defined interface between modules which allow components to be swapped, upgraded, or replaced independently. So, this independence ensures that one modular can evolve without forcing redesign in the entire system. For example, upgrading a laptop's RAM or replacing a printer cartridge demonstrate modularity's advantage. Okay, so this flexibility contrasts sharply with integral architecture, where tightly coupled functions may make upgrades or repairs difficult. So a change in one component often requires a significant rework elsewhere, reducing the adaptability of the product. So, fixed unsaid design, meanwhile, are unique and not designed for a modular replacement. So, the upgradability of modular design support a long-term sustainability. Okay, and customers benefit from a extended product life cycle, while manufacturers gain opportunities to introduce a product variants without redesigning from scratch. So therefore, modular architecture is not just a technical design choice but also a business strategy to, to accommodate the evolving technology and customer expectations efficiently. Okay, you may go through this slide. Next is question number 12. What is the primary drawback of integral architecture? Is it poor performance optimizations, limited repair and upgrade options, increased production cost, or low initial design effort? What will be the right answer?
B and C.
B and C. B is the right answer only. So basically, integral architecture prioritize the compactness and high performance by merging a multiple functions into a fewer components. While this yields the tightly optimized design and it creates significant challenge for repairs and upgrades. So components cannot be easily isolated, meaning a fault in one area often impact the whole system. So the so this limitation is particularly evident in high performance systems like aircraft engineer or smartphone. So while the performance is maximized, repair and modifications became costly and time consuming. So sometimes requiring complete replacement rather than practical fixes. So the key trade-off here is between optimizations and adaptability. So designers must balance the whether performance gain outweigh the risk of reduced flexibility. So thus, the primary throwback of integral architectures lies in its lack of modular independence, making it unsuitable in contexts where frequent updates, customizations, or serviceability are important. Okay. So limited repair and upgrade options is the right answer. So as I have written here, the widely integrated architecture optimize the compactness and performance, and it makes the upgrade repairs difficult because functions and tightly coupled. Okay, go through yourself. Okay, those who are watching this video later. So moving towards the next question, question number 13. Which of the following best describe bus modular architecture? Can you answer?
B option.
Okay, D option. So bus modular architecture is defined by uh, a shared communications or a structural backbone that connects the multiple models. So each module plug into the bus and can exchange energy informations or material through this common interface. So a classic example is the USB system in a computer. So where many peripheral connect to a single bus without needing unique slot. So this step uh, step enables the scalability, interoperability, making it easier to add or replace modules. So without redesigning the entire system. So compared with slot modularity, which requires dedicated slot interface and sectional modularity. So which arrange modules sequentially. So bus modularity provides a more flexible and standardized system. So fixed unshared design do not allow this level of interchangeability. So the effectiveness of bus modularity lies in its ability to simplify connections while supporting variety and scalability. So making it highly valuable in electronics and automotive systems. Okay. Now, so B is the right answer. Module connect to a common backbone or bus. Okay. Now moving towards the next questions. Question number 14. Which of the modularity is best represented by ink cartridge in a printers? Is it sectional modularity, bus modularity, slot modularity, consumable modularity?
Slot modularity.
Bus
C
modularity.
option.
B.
Slot. C.
Okay, slot modularity. Okay. No, but C is not right answer. So the right answer is consumable modularity. Consumable modularity refers to modules that are designed for a frequent replacement because they are consumed or worn out during use. So printer ink cartridges are textbook example. So as they deplete with use but can be easily replaced to restore functionality. So this approach ensures that the core product remains functional over time while only the consumable part is replaced. So it reduces the waste, minimize downtime and create a recurring value for both user and manufacturer. So unlike slot or bus modularity, consumable modularity focus on wear and tear components that must be replenished, and batteries, filter and pen refill are other example that fit this pattern. So the strength of consumable modularity lie in its practicality. So by isolating the high uses parts into independent modules, so designers simplify the maintenance and extend the product's useful life. Okay. So the right answer for this question is option D, consumable modularity. And those who are watching this video later on, kindly go through this slide. This is a very small explanation part of this particular question. So yeah. Now moving towards the next question, question number 15. Which of the following clustering criteria ensures the future uh, proofing of the product? Is it grouping by manufacturing process, grouping changing technology as a separate modules, combining all high performance component into one block, or designing with minimal interface? What could be the right answer?
D.
D. Designing with minimal interface.
No.
B.
Grouping fast changing technologies
Okay,
as separate modules.
okay, grouping fast changing, yeah. Mm, yes, B is the right answer. So, what could be the explanation? It is saying which of the following clustering criteria ensures the future proofing of a product. Okay, so one effective creation in clustering for modularity is to isolate a fast changing technology into a separate module. So this ensures that when a new innovations emerge, only that specific module needs to be updated rather than the entire product. Okay. So for instance, in a smartphone, the display and processor evolve rapidly. So they are often designed as a separate modules. So this allow manufacturer to introduce upgrades more easily while keeping other systems stable. So grouping by manufacturing process or minimizing interface may simplify a productions but does not directly support the adaptability. So similarly, combining high performance component into one block might boost the optimizations but limit the flexibility for future change. So therefore, the separating fast changing technology into independent modules is the most effective way to ensure the product remain relevant and adaptable in the evolving market. Okay, so B is the right answer. Okay. Now moving towards the next questions. Question number 16. Which heuristics methods identify modules by tracing a major flow that branching into several subflow? Convergent transmissions, dominant flow, branching flow, or transmissions flow? What could be the right answer?
Branching flow.
Yes, correct. Branching flow is the heuristic used in module identifications where a dominant functional flow split into multiple subflow. So this branching point becomes a logical basis for creating a distinct module. So for example, in electrical systems, power from a battery may branch out to supply a different subsystem such as lightning, sensor and control units. Okay, so each branch can be treated as a separate module because it serves as a unique function. So this heuristic differs from a conversations or transmissions, so which emphasize the transforming energy or material and from dominant flow, so which highlights a single primary pathway. So transmissions flow meanwhile focuses only on movement without branching. So branching flow provides a systematic way to to organize product functions, ensuring the clarity in module boundaries and reducing unnecessary in interdependence across the design. So branching flow is the right answer for the question number 60. Okay. So moving to the next question, question number 17. Which of the in which situation is integral architecture most appropriate? Is it product requiring frequent customizations, product where compactness and high performance are critical, product intended for modular family expansions, products that evolve rapidly with technology? What could be the right answer?
B.
D for Delhi.
B. B.
Oh,
B for Bombay.
Bombay. Okay. Product where compactness and high performance are critical. Okay. In which situation is integral architecture most appropriate? Yes, B is the right answer. So basically, integral architecture is the most appropriate when compactness and performance are critical requirements. So by tightening linking functions into a shared components, designers achieve efficiency, speed, and reduce the size. So applications such as aircraft engineer, high performance electronics, or racing vehicle often demand integral design. So in these contests, optimizations outweigh the need for adaptability, making the integral architecture the superior choice. So customizations, modular family expenses, and adapting the rapid technology changes are better served by a modern architecture. So these situations prioritize the flexibility over a maximize optimization. So thus the integral architecture is selected strategically when performance cannot be compromised even at the expense of reparability or flexibility. Okay. So B is the right answer. As you can see the explanation part here, that integral architecture is the ideal for applications like aircraft engine. Okay, so you may go through this slide. Now moving towards the next questions. Question number 18. What is the primary purpose of module heuristic? Is it estimate product cost and revenue, or identifying the natural cluster of functions and components, minimize the standard deviations in customer preferences, or define the marketing mix for product family? What could be the right answer?
B. Identify natural clusters of functions and components.
Okay. So basically, modular heuristic serves the purpose of identifying the natural cluster of functions and components in the product, and they provide the design rules that help the break down complexity into manageable units. So by analyzing the dependencies and flow pattern, heuristics ensures that each module is logically coherent, so enabling better manufacturability, maintainability, and upgrade potential. This is not about cost estimations, marketing strategy, or customer preference analysis. So therefore the primary role of module heuristics is to simplify complex systems by grouping the interdependent elements into modules, creating a strong foundation for a efficient product architecture. Okay, so the right answer is option B. Identify natural cluster of functions and component is the right answer. Okay, now moving to ask the next question, question number 19. Which of the following is the key Advantage of sectional modularity. Can you answer?
A.
Option A. Okay. Think this question again. Okay, let me give you the hint. So the the hallmark of sectional modularity is its flexibility. Okay, and and the product design with this architecture can be extended or reduced by adding or removing the sections, so offering adaptability without major redesign. So examples include office furniture system, slaving and drill bit sets where users can customize the set up to meet the specific need. So this scalability makes the sectional modularity highly user friendly. So unlike a bus modularity or slot modularity, sectional design rely on a sequential arrangement and integral design prioritize the compactness over flexibility. So thus the ability to freely add or remove unit as a need represents the key advantage of sectional modularity, supporting the both user customizations and efficient product management. Okay, so is the right answer. Okay, those who are watching this video later, please go through this slide. Next question number 20. Which of the following best describe the role of concept in a product design? Is it provide a market study of customer demand, gives concise descriptions of how the product satisfy needs, lists the complete manufacturing specifications, or define the cost and revenue of product families?
A and B.
Okay, A and B. Okay, so basically a concept play a pivotal role in a product development by providing a concise descriptions of how the product will meet the customer need. So it translates the abstract requirements into a clear directions for a design. So concepts act as a communications tools among stakeholders, so ensuring that everyone understands the product's purpose and expected benefit before moving into detailed development. So unlike a manufacturing specifications or cost studies, concepts focus on functional intent and user satisfaction. So they serve as the functions on which detailed design and engineering decisions are built. So therefore, the concept is the essential bridge between customer needs and design executions. So guiding the product's journey from idea to a realizations. Okay. So the right answer is B only, gives a concise descriptions of how the product satisfactions needs. As I have written here, a concept bridges the gap between customer needs and technical solutions, and it describes the product's intended functions, benefits, and architecture at the high level, enabling the stakeholder to evaluate the feasibility before detailed design and manufacturing market study and costing follow one the concept is validated. So B is the right answer. Okay. Okay, so yeah, thank you so much. I hope this will make some sense. Okay,
Thank you, sir.
you're welcome. Do you need a summary also, because I have already covered before you joined the class?
No, no, sir. I will watch it later.
Okay, fine. So only you attended last time. There were several people, but again,
Yes, yes.
Anyway, so how is your course going on? All good?
Yes, sir. All good.
Okay, fine. Chalo then, thank you so much. Okay, see you in the next
Thank
week.
you, sir.
Okay, okay,
Yes,
bye bye,
yes, sir.
bye bye.